Hello learners, today in this video we will learn the concept of plane rotation method or otherwise called the trapezium method for drawing the projections of lines inclined to both the planes. So let me just, in the previous videos we had seen the concept of the line rotation method. Let me just compare it to compare the trapezium method to the line rotation method. So basically, uh, in the line rotation method, in the questions that deals with line rotation method, the true length will be given and the inclination will also be most probably given. Okay, and the objective will be to find the top and the front view. Okay, generally speaking. And in the plane rotation method or the trapezium method, the top view, the front view will be given, that is the projections will be given, and you will be asked to find the true length or the true inclination and also to find the traces, and these things is easily better found out using the plane rotation or the trapezium method. So we'll see what the concept of trapezium method is. Okay, so we have this model here. This gray is the vertical plane, as you know, and this blue plane is the horizontal plane. So we have this line here, AB, which is inclined to both the planes. It is inclined to the vertical plane and it is inclined to the horizontal plane also. So we have this here. Let me show this to you from all the angles. We have this line here, which is inclined to both the planes. Okay, so let me draw the projections of this point of this line here. That would be, so we have this front view and the top view. So let me name this now. So we have the A dash B dash, the front view, and the AB, the top view. So as you can see here, you have got the projectors. You've also got the projections. Let me also draw the other projectors. Okay, so this is how we are able to draw the projections, or how this line inclined to both planes is projected towards the vertical and the horizontal plane. So now let me just make this into a plane. I will be joining A dash B dash B A. This These 4 points will be joined by using a plane. Okay, so let me do that now. Let me just color it. Okay, so now again I will be drawing another plane here, joining A B B A. Okay, this plane, again it is also a trapezium. All right, so what we have done is we have taken the AB here, that is the line that is inclined to both the planes, and we have created planes connecting that true length with its projections. Here it is the front view projection, here it is the top view projection. Let me also color it so that you can differentiate. Okay, okay, so here if you can see this, we have two planes that was created and it has the shape of a trapezium. Now I'm trying to do something. I will try to rotate it about A dash B dash. I'll rotate the yellow plane about the axis A dash B dash. Okay, so in what direction will I rotate it? Let's see. Okay, in this direction. All right. So I'll be rotating that in this direction. So let me just rotate it now again. All right. Basically, I've rotated this plane along the axis A dash B dash, and I've placed that on the vertical plane. Okay. Similarly, I will be rotating this red plane about the axis AB, that is small a, small b. Okay. Keeping that on the horizontal plane. All right. So in which direction did I rotate it? I rotated it in this direction. Okay. So if you can keenly observe here, what do you see? So basically all I did was I rotated that trapezium that I've got. And what do I get here? As you already know, this AB, this line that is highlighted now, that is the capital A, capital B, that line represents the true length of the line. That is the actual length of the line. So when I'm rotating it like this about the projection line, that is A dash B dash, that is the front view of that line AB, what happens is that this true length is the same as this line here. So let me just point out or name these points also. This will be A1, it will be B1, this here will be A2, this here will be B2. So what do we have here? Just by rotating this plane, what we have got here is that A1, B1 has the same length as AB, that is capital A and capital B. Similarly, A2 and B2, A2, B2, this line here, it has the same length of AB, capital A, capital B, which shows that A1, B1 and A2, B2, it is actually the true length of the line. And I got this just by rotating those planes about the projection of the front view and projection of the top view. All right. So basically just by doing this, you can get the true length of the line. As we have already discussed in the question related to trapezoid method, you will be given the lengths, most probably you will be given the lengths of the front view and the top view, the positions of the front view and the top view. You will be asked to find the true length. So just by doing this, you can do it. So when you're drawing it in a piece of paper, what you've got to do is, if you can look into it, this line here is actually perpendicular to A dash B dash. This line here, that is A dash A1, this line is perpendicular to A dash B dash. Similarly, B dash B1 is perpendicular to A dash B dash. And if you look at the red planes here, the points here, this line here is perpendicular to perpendicular to the top view, and B to B, that is perpendicular to AB again. Okay, and on top of it, if you can see this length A dash A is equal to A dash A1. Similarly, B dash B equal to B dash B1. And again, A to A is equal to A A, and B to B equal to B capital B. Okay, so you can easily draw this when you are drawing in a piece of paper. You just have to take these measurements, which is the distance from the XY line. It is the, if you're talking about this length here, that is A dash A1, all you have to do is measure the distance of the point small a from the XY line. Similarly, if you want to mark the distance here, that is B dash B1, all you're going to do is you got to measure the distance of the point B, small b, from the XY line. Alright. Similarly, here in this case, that is small a, capital A2, that length is just exactly the same as the distance of A dash from the XY line. Similarly here, that is B2 is exactly the same as the distance of B dash from the XY line. So keep that in mind when you're doing it. So just by drawing some perpendicular lines and taking the measurements of the points from the XY line, you are getting the true length. It is that simple. So is this the only information that can be derived out of from trapezium method? No, because you can get further information from this. So let me just extend this. So let me just extend this true length of the line towards the vertical plane as well as towards the horizontal plane. So if extended, the line will meet the vertical plane here at this point. Okay, and it will intersect this point at the it will intersect the horizontal plane at this point here. If you can see this line, this is actually the line in question, that is capital A capital B, and it will intersect the horizontal plane at this particular point. Please do note that. Okay, so now if I am extending this line, that is the projection of the front view projection of the line AB, then what will happen? Okay, I've drawn that. Okay, and then again I am extending this. Okay, so if I'm drawing a line through these guidelines here, okay, so this angle, so this capital AB has been extended towards the vertical plane, and I have also extended the length or the line A dash B dash. And if I am going to measure this angle here, okay, I get around approximately 27.1 degree. So what is this 27.1 degree? It is the inclination of the line AB to the vertical plane. Okay, so now just by looking at this line, that the line that we have got A dash A1 B1, capital A1 and capital B1, if I am going to extend this line here, join these guidelines also, and if I'm going to measure that angle, it is also 27.1. Obviously it makes sense, right? This plane has been rotated here, so this angle is equal to this angle. So when you are drawing the projections now, okay, when you are drawing the projections now, let me just take it to the front view. Okay, this is the front view. So if you are drawing the projections, you have got this a1 and b1, and if you are just extending that line and the projection, front view projection, and they intersect at a point, and the angle between those two lines will actually give you the actual inclination with the vertical plane. Okay, I hope you understood that. Similarly, the same thing is happening here with the horizontal plane also. So let me just extend this line now. That is the top view projection. Okay, I extended that line. All right, extended the, okay, and okay. So if I draw a line here extending from the actual line AB, then I am extending that the top view projection, then I am extending from the new points, that is A to B2. Okay, they all intersect at the same point here. All right, so what we have here is, if I'm going to measure this angle here, if I'm going to measure this angle, it's from here till here, it gives me around 43.1 degree. Okay, and what is this? This is actually the inclination of the line AB with the horizontal plane. And in order to get this angle, you just got to measure. If you are measuring this angle also, you will get the same thing, that is 43.1. So basically, the angle here, this angle that is formed in the horizontal plane, it is also giving you the actual inclination with the horizontal plane. So if you are looking from the top, if you are looking from the top, as you can see this here, so this is your top view. Okay, a small b, and you have drawn the perpendicular lines here, and you have marked the points of a2 and b2 here, and then you have extended those lines, and then you have intersected those lines, and you are measuring this angle, and that means that this angle is actually giving you the inclination with the HP. Okay, so by using trapezium method, we have now found the true length of the line and also its inclination with the horizontal plane as well as the vertical plane. Now, is that all you can derive or extract from the trapezium method? No, because you have further one more thing that is available here. The line AB is intersecting the horizontal plane here, and what is that intersection point? That intersection point will be called as the, obviously it is the horizontal trace. Okay, similarly, if you are looking at this point is actually the vertical trace, that is the intersection of the line with the vertical plane. All right, now if you have extending this line to this point here, let me just do that also. Okay, similarly, okay, so what is this point here? This is VT, and the top view of VT will give you V. And what is this? The front view of HT will give you H dash. So I hope we have all completed the entire thing. Let me just delete all the guidelines so that it makes better sense for you. Okay, so let me just revise it. Capital A, capital B, that was the actual line. Then we have made the trapezium with the front view projection as well as the top view projection, and I had made it the yellow plane and the red plane. What I did was I rotated the yellow plane about the axis of the front view projection, that is A dash B dash, and I've got this. And then I rotated the red plane about the axis of A B, that is small a and small b, that is the top view projection. And then I rotated it about that particular axis, and then I placed that in the horizontal plane. So just by measuring these new points, I got the points as A2 and B2. This A2, B2 will be the true length. Similarly, A1, B1 will also be the true length. And if you're extending A1, B1, okay, towards this side, and you are also extending the front view, that is A dash B dash, the point of intersection will be the VT, and the angle between it will be the angle of inclination with the vertical plane. Similarly, if I am extending the actual line here, if I am extending AB, that is the top view of line AB, and A2 B2, and if they intersect at that point is the horizontal trace, and the angle between them will give you the inclination of the actual line AB with the horizontal plane. This is the concept of the trapezium method. It is called trapezium method because these planes here, it is a trapezium, and these planes are rotated, therefore the name plane rotation method, in order to find the true length, true inclination of line inclined to both the planes, that is the horizontal as well as the vertical plane. I hope you got the concept here in this video. Thank you. This is Deepak B, Assistant Professor Civil Engineering, GC Thrissur. We will see how we use this concept to solve a problem in the next part of this video. So do check that out. Thank you.